Okay, now that we're feeling a little more comfortable with recursion and we've seen a couple examples, let's talk about how to combine the last lab with sorting and recursion. So there's a way that we can think about sorting recursively that will allow us to design a faster algorithm for sorting than insertion sort that we saw. So remember when we did the Fibonacci and all that, we assumed our recursive way of thinking is saying, well, if I know how to solve the Fibonacci of, I say Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. And I'm kind of assuming here that I know how to solve Fibonacci of n minus 1. Like, I'm going to put that off for a second, and that's going to happen in its own call. And I know how to compute Fibonacci of n minus 2. So when we think recursively, we're like, yeah, assuming I know how to do this, what would I do to put them together to get Fibonacci of n? So in this case, I would just add them. So we can think in a similar way about sorting. We can break down our problem of sorting into two halves. And we'll work on each, we'll pretend that we just know how to solve each half individually, and then we'll figure out how to put them together. So that's the strategy. And it's called divide and conquer. This is a common recursive strategy. So what we're going to do is we're going to say, okay, look, I'm going to split this thing into two parts, and I'll just figure out how to sort each part. I'm assuming that I can do that. Okay, that's what we always have to do in recursive things. Like, okay, I've sort of been able to sort the first half and the second half individually. So I'm just going to eyeball that here. Okay, so that's what that one would look like once it was sorted, and this one would look like more like this. Okay, so now they've been sorted. So again, I assume that that can happen. I've split them in half, sorted the first half, sorted the second half. Now the question is, to complete the recursion, I have to figure out how to put the first half together with the second half. So what I'm going to do actually is keep track of, put these little circles on top of elements in each half. So what I'm going to do is start at the left side of each one of these. And what I want to do is somehow combine these together so that I have my full list of 10 items in ascending order. So what I'll do is I'll compare the two items with the ball over them and see which one is smaller. So in this case, this item here on the right one is smaller than the one on the left one. So I'll put that first. I'll move the ball along to the next element on the right. Okay, now I'll compare this one to this one. Well, this one's smaller, so I'm going to move the ball to the right, take that one. Okay, that one's next. Now I'll compare this one to this one. Well, actually, this one's a little bit bigger, so I'm going to take the smaller of the two, which comes from over here this time. Move that over. Okay, now I'll compare this one to this one. This one is smaller, so I'll take that one. Move the ball over. Okay, now I compare this one to this one. This one is smaller, so I'll move it over. Move the ball up. Compare this one to this one. Well, this one is smaller. Move it down, move the ball over. Compare this one to this one. Well, this one's smaller, so compare that. Move it over. Okay, this one to this one. Actually, this one is smaller, so we'll move that one down. Move the ball over. Compare this one to this one. Well, this one is just slightly smaller. So move that one down. And now we're actually out of stuff on the left, so whatever's left on the right, we can move over. So that's called the merge operation. And we can actually say, you know what, I'm going to do that at every level. So I'm going to do a merge on the first half, and then I'm going to do a merge on the second half. I'm going to put them together this way. And that whole process of recursively sorting things this way is called merge sort. And this is actually what the arrays.sort method in Java implements. So, like I said, I could actually, to figure out how to sort the first and the second halves here, I could actually, start like this. And then do a merge sort on the first half of the first half and the first half, or the second half of the first half. So I'm going down deeper in the recursion now. Let me ignore this. I'll get to it later. I'm saying in order to sort this before, what I would have done is split this in half as best I could. I mean, there's not an even number of elements, but I'll take the first three and then the last two. And I'll do the same thing. So I'll say, look, I'm going to assume that I can sort the first half properly and the second half properly. And now I'm just going to merge them. So same thing. So I compare these two, this one's smaller, move this over, compare these two, this one's smaller, move this over, compare these two, well, this one's smaller, move this over, compare these two, this one's smaller, and then I'm out of stuff over here, so I'm just going to put that one over. So you can see we can use the same strategy to keep going. And then once we get small enough, once we're left with just one or two elements, it's trivial to sort them. Okay, so that's how the recursion goes. Like, I'm assuming I know how to do the first half, but actually, once I go into the recursion on the first half, I see I actually do the same thing. So I take this down, split it in half, and then merge them. Okay. So that's how merge sort works. So let's see if we can start throwing down some code to accomplish this in Java.